Good morning. Today we will present on our group project titled Protection Against Overvoltages for subject Electrical Installation interim semester 2020 and 2021. This is the list of our group members, and I'm ADIBAH. I will present the introduction part. Protection is a very important part in a power system where the main objective is to protect the system from faults and overvoltages, and also to increase the reliability of the system by minimizing the time taken needed to clear the fault. As an electrical engineer, in deciding protection devices, there are a few aspects needed to be considered, which are the power system design, the location, and also the customer demands. As the customer demands increases, the rating and also the amount of protection device should be increased too. Next, overvoltages are defined as voltages that temporarily surpass the threshold value of the main voltage, and it can be classified into two types, which is the temporary and transient overvoltages. Temporary overvoltages generally have a waveform shape that is slightly damped or undamped and longer period of time. Meanwhile, transient overvoltages has a highly damped waveform and also a very short period of time, and it occurs over a very short period of time. Next, I will pass to my next group member to present the technical parts.
Assalamualaikum, my name is SHARIFAH and I'll be presenting about surge arresters. So there are many ways to protect an electrical system from overvoltages, but one of it is to install surge arresters. So when a lightning strikes an area, the area will have a surge in energy, which means that the voltage will increase. So this surge arrestor is a device which is installed at the power board to protect the electrical appliances from damaging power surges. These damaging power surges could destroy electrical appliances. How does this surge arresters work? It works by capturing excess voltage that is not needed by the electrical appliances and directs it to its ground wire. So this ground wire will lead the excess voltage to the earth. In the process of capturing the excess voltage, it won't disturb the normal voltage that is needed by the electrical appliances. So inside this surge arresters contains metal oxide varistor, MOV. This metal oxide varistor links the surge arrestor's hot wire with its grounding wire. The metal oxide varistor can vary the electrical resistance, which means that it could make adjustments to the incoming voltage. This incoming voltage comes from the hot wire, so the MOV will redirect the excess voltage to the grounding wire, which will be channeled to the earth. Hence, the normal voltage gets to flow normally and the operation of the electrical appliances won't be interrupted. So this is one way to protect an electrical appliances from overvoltages. That's all from me. Thank you.
Hello and Assalamualaikum everyone. My name is SYED binti SHAHRIL. I would like to proceed presenting another type of overvoltages protective device, which is the rod gap. What is rod gap? The rod gap is the most common frames of protective device used for overvoltages protection, especially in terms of lightning arrestor. Other than the typical rod gap as shown in the figure, we have the horn lightning arrestor and multi-gap lightning arrestor. Rod gap is the most common used device because it is a very simple type of diverter which consists of two rods bent at a right angle with a gap in between. As shown in the figure, the gap between the insulator and the rod gap, denoted as P, usually will be not less than 1/3 of the gap length to provide safety measures for the insulator itself. The configuration for the rod gap is the upper part. The upper rod will be connected to the line circuit while the bottom rod will be connected to the earth. Next, we move on to the principle of a rod gap. Rod gap basically behaves like a non-linear resistor. Under normal operating conditions, rod gap will remain as non-conducting equipment. On the occurrence of high voltage surge, spark will be produced at the gap, then the surge current will be forced to be conducted to earth through it. In short, rod gap provide a low resistance path for surge to be conducted to earth harmlessly. And normally, road gap will be adjusted so that the breakdown will occur at 80% of the spark voltage. The next slide shows the limitation of the rod gap. Even though rod gap is the most commonly used device for overvoltages protection, its limitation needed to be considered. The limitation of rod gaps are: the rod itself may melt or damage due to the excessive heat produced by the arc. Then, the performance of the rod gap is affected by the climatic conditions such as rain, humidity, temperature, and etc. And the polarity of the surge also affect the performance of the rod gap. As conclusion, due to this limitation, rod gap are usually used only as the backup for the main arresters. And that's all for rod gap. Thank you.
Hi everyone, my name is Winnie and I will be presenting another method of overvoltage protection, which is to build a crowbar circuit. A crowbar circuit is made of resistors, capacitors, diodes, thyristor, and also fuse. So based on the figure shown, it is placed across the power supply's output terminals. When the overvoltage occurs, the crowbar circuit will result in blowing the fuse and disconnect the power supply from the circuit. Next is we'll be going through the working of a crowbar circuit. So the Zener diode is the one that detects the overvoltage. The threshold voltage of the Zener diode is selected according to the output voltage of the power supply. It is usually set to 1 volt, more than the supply's output voltage. The Zener diode starts conducting when the voltage reaches its threshold voltage. If the voltage continues to increase, the voltage drop across resistor 1 and gate terminal of Q1 will increase. In normal conditions, R1 will act as a pull-down resistor for the gate terminal of Q1 to keep it in low condition. When the voltage of the gate terminal of Q1 increases until it reaches more than the threshold voltage, the thyristor will start to conduct. This will result in a short circuit and it will blow the fuse, while the other components such as the capacitor 1 will reduce small voltage spikes to avoid unnecessary triggering of the circuit, whereas capacitor 2, it avoids unnecessary triggering of the thyristor. Overall, the overvoltage protection using a crowbar circuit is cheap and easy to conduct, while it protects expensive equipment from serious damage. Thank you, that's all from me.
Okay, the another way to protect the power system from overvoltage is to apply the earning screen. Okay, the power station and the substation are generally house expensive equipment. So the station can be protected against the direct lightning strike by providing the earning screen. So the earning screen consists of the copper conductor, which is called by screen or shield, that are mounted all over the electrical equipment in the substation or in the power station. So the screen also is properly connected to the earth on at least 2 points through the low impedance. So this method is very simple and low cost, but it could not protect the equipment from traveling wave. So to protect the equipment from traveling wave, another protection device should be installed, which is ground wire. So as we all know, one of the cause of overvoltage is lightning strike. The most effective method of providing protection of overvoltage through the transmission line against the direct lightning strike is by using the ground wire. So the ground wire are placed above the phase conductor at such position that practically all the lightning strike are intercepted by them, as shown in the picture. And it is also attached from one tower to another tower. So the ground wire has a role of shielding the line and intercepting lightning strike before it hits the current carrying conductor below them, which is the power line itself lah. So the earth wire will intercept fascias and advert to the ground, so the power line will not affected. Okay, for the better protection, it is essential to install 2 ground wire instead of the 1 ground wire. So this method beside provide as a protection, it is also can be a solution to reduce trips at place where are commonly struck by lightning. So when the lightning strike an earth wire, the wave are produced. So this wave will travel the opposite direction along the line until it reach the adjoining tower. So when it reach the tower, it will be directed to the earth safely, which will make sure there's no power outage will occur. So for the better protection, for effective protection, the resistance between the earth and the tower base should be low as possible.
In conclusion, it's very important to choose a suitable protection devices for the power system, as protection can help in various ways, such as reducing the aging of insulation, minimizing the frequency of maintenance work needed, and also reducing outages of lines and substations. The best scenario would be when the protection devices can be beneficial both in terms of technical and cost effective. That's all from us. Thank you.